And thanks to the organizing committee for giving us the chance to share Canadian experience with deterioration of concrete incorporating sulphide-bearing aggregates. The main topic of the presentation today will be related to the link between the research and actually the standard development. Next slide, please. So, very nice presentation by Dr. Lehman. We all know that pyrite and pyrrhotite are common minerals in various rock types. Next, please. Yeah. And in the presence of oxygen and water, iron sulfides will oxidize and to form rust and sulfuric acid. Next slide, please. So, since the early 1990s, rapid deterioration has been observed on housing foundations and other building in the Trois-Rivières area, which is located about 200 kilometers northeast of Montreal in Quebec. And legal actions were filed actually since the early 2000s related to this process. Next slide, please. Damage was yes. So damage was noticed not only in housing foundations but also in commercial buildings, and in many cases the end result was actually to replace the housing foundation, as you can see on the two pictures on the right hand side of the slide. Next slide, please. So basically the aggregates that were used to in the defective concrete were produced from two quarries located in the north part of Trois-Rivières, which is located, as I said, about 200 kilometers northeast of Montreal. And you can see pictures of those two quarries and lots of signs of oxidation, as you can see in the rock material extracted from the quarry. Next slide, please. So the rock involved there is an intrusive magmatic rock, which is called a gabbro, with sulfide contents that could reach up to 7%. And the sulfide minerals identified were mainly pyrite, pyrrhotite, with traces of chalcopyrite and pentlandite. So chalcopyrite is a copper-based sulfide, and pentlandite is a nickel-based sulfide mineral. And as you can see here on the two slides in the middle, two pictures in the middle, you can see that the presence of biotite, which is a mica, some feldspars are highlighted also in the rock, which may play a role in the deterioration process. Next slide, please. So in the early 2010s, a collaborative research and development grant was received and led by my colleague, Professor Duchesne at Laval University. And this grant actually, through this grant funding was attributed to the research team, and the money was actually collected from about 16 partners, including industrial partners and also government organizations. So that grant actually allowed us to carry on the research in two universities, at Laval University, Ryerson University in Ontario, and also with colleagues from Hydro-Québec. Next slide, please. So about the activities that we did as part of the research program, we actually developed some outdoor exposure sites. In the first case, the first site was developed with the use of blocks that were extracted from housing foundations before their demolition. So those blocks were installed on a site, and then they were followed and monitored with time. And we also developed another site at Hydro-Québec where actual new blocks were made with different mixed design and rock types in order to evaluate mechanistic processes involved in the deterioration process. Next slide, please. So we were able, through the examination of concrete cores from those concrete affected by this deterioration, we examined the cracking, the development in the concrete, in the aggregate particles. We highlighted the presence of the sulfide minerals, as you can see here by the red color faces in the aggregate particle in the middle picture, which is pyrrhotite, And in the upper part, we see some secondary sulfates that have been released through these internal sulfate attack of those pyrrhotite phases present in the aggregate. Next slide, please. We were able also to identify the mechanisms involved in the deterioration process, along with the appearance of the various products of deterioration, as highlighted and well explained by Dr. Lehman. Next slide, please. And a big part of the project actually focused on the development of what we call a testing protocol. So on the basis of 8 aggregate materials, coming from Trois-Rivières, where the problem was identified, but also we collected some materials from Europe, which have been identified in scientific papers as problematic through pyrrhotite reaction. So we developed a range of different test methods in order to evaluate the potential reactivity of the aggregates tested. The test methods actually use the total sulfur determination, the oxygen consumption, petrographic examination, and a mortar bar expansion test. And this was done actually through the PhD work of Andrea Rodriguez here at Laval University. Next slide, please. So in parallel to the research, a group of people working in the CSA, Canadian Standard Association Committee on Concrete, developed a protocol as part of the standard. So this informative, not a protocol, but an informative annex, where we actually give information for engineers related to this deleterious reaction in concrete. Next slide, please. So this annex included some general information on sulfide minerals, the oxidation process, a literature review, a review of standards around the world, and also a discussion at the end to give some highlights and some recommendations to engineers on how to deal with this issue. Next slide, please. That was the first phase that lasted from 2010 to 2014 with the publication of the edition of the concrete standard that incorporated that Annex P. In the next cycle of the standard, which lasts 5 years, the committee continued to work in standardizing the result of the research. And what was done actually between during that period from 2014 to 2019, the research of the results of the research were incorporated in the new version of protocol P of the Annex P. Next slide, please. In this new version of the Annex P, we kept the actually introductory material that we had developed for the previous cycle of the standard. Next slide, please. But we also incorporated the performance evaluation protocol that was developed through the PhD work of Dr. Rodriguez, and 3 test methods that allow to evaluate the potential reactivity of sulphide-bearing aggregates. Next slide, please. So this is the so-called protocol, which looks a bit complicated, but basically it involves a step-by-step approach to evaluate potential reactivity of sulphide-bearing aggregates through potential condition survey in the field and laboratory investigation program. Next slide, please. So if we simplify that sketch that we just saw, then the step-by-step approach is characterized by the sampling of the aggregate in the quarry that you want to evaluate, preparing the specimen for testing in the laboratory, and then a number of steps relating to different test methods that can be used. Next slide, please. Yes. So okay. Thank you. So the first step in the process is the evaluation of the total sulfur content in the aggregate material. This is done with a furnace, as you can see in the upper part of the slide. We use also petrographic examination in order to identify the presence or not of pyrrhotite, which is the main reactive constituent in the rock there. Depending on the amount of total sulfur and the presence of pyrrhotite, then the aggregate can be accepted for use if there is low sulfur content and no pyrrhotite present. But if pyrrhotite is present in the aggregate, then we go to step 2, which is the oxygen consumption test. It's the picture in the middle of the slide there, where we see that the ground aggregate material is at the bottom of the container with a probe at the surface, which measures the consumption of oxygen in the container. And depending on the results there, if the aggregate fails or not the limit, then we pass to the motor bar test, which is at the bottom there. Next slide, please. The motor bar test basically is the end part of this testing protocol. It will allow to finally identify which aggregate are going to create destruction, if you like, of the mortar material or the concrete, and a non-reactive material will actually keep the mortar specimen in good condition, as you can see there in the middle part. Next slide, please. So we are now in the third phase of the standardization process. We are still trying to improve our testing protocol, the Annex P in the standard. We want to actually make this Protocol P to go from the informative part of the document to the mandatory part of the document. Next slide, please. And we're doing that through another research program that is funded by the Canadian and the Quebec government in Canada. We have a project team which consists of a federal body, the National Research Council of Canada, Laval University, Ryerson University, and partners from government and also CSA Group. Next slide, please. Through this program, we have organized stakeholder workshop series in order to increase the awareness about pyrrhotite situation across Canada. Next slide, please. We're also carrying, I say we, but it's the Geological Survey of Canada is carrying a risk analysis on pyrrhotite distribution in Canada through the analysis of data from the mineral deposits across the country, as you can see there. And we saw that from the geological map in the US, that the presence of pyrrhotite is very much related to the geology in Canada. Next slide, please. Then we want to improve the test methods in the Annex P of the protocol. Next slide, please. And in order to do that, we actually are organizing an interlab study across Canada where participants will be testing aggregate material in different labs in order to make sure that we are doing the testing properly in the different parts of the country. And this will allow us to move, hopefully, the standard test procedure from the informative part of the standard to the mandatory part of the standard. Next slide, please. Other activities, we continue our work on mechanistic studies. We are in the process of instrumenting some housing foundations in order to better understand the environmental effects. Next slide, please. We're testing more aggregates across the country to determine the extent of the situation. We're developing an expansion test on concrete specimens, and we're starting some collaborations with other research teams in the US, Norway, and Japan. Next slide, please. So in conclusion, we know that sulphide-bearing aggregates have shown to be deleteriously reactive in concrete in many parts of the world. Such reactions we have seen can cause serious damage to affected concrete elements and structures. Next slide. And through R&D program, we've been able to develop some test procedures, and now we are in the process of introducing those in the Canadian standards, in the mandatory part of our standards. So yes, it shows that we can use research in order to affect the standards development in a country. And next slide, please. I would like to just thank all the organizers, our partners, and also the attendees for being present in this seminar. Thank you.
Thanks so much, Benoit, for a really excellent talk on the situation in Canada. And you presented a really clear picture of the actual rigor of how you guys are approaching understanding how to test for the presence of these deleterious minerals, and also how they're impacting on concrete back home. I think it's really excellent that you highlighted that there's actual really strong desire for the Canadian Research Councils, for example, to fund this type of research, and it's clear that the same type of commitment needs to be happening in Ireland, maybe from someone like a Science Foundation Ireland or large government grants, because we really need to get to the bottom of this and to develop our expertise in this field.